Hi everybody, welcome back. Today we're going to be talking about simplifying rational expressions. Last week and yesterday we were still practicing how to factor, and since we're getting really good at it, I think it's a great idea just to dip a toe into something a little bit new, a little bit different. So we're going to be simplifying rational expressions. So before we can do any simplifying, we need to know what is a rational expression. So a rational expression if you look at the word rational, it has the word ratio in it, which means we're going to be looking at fractions. So a rational expression is a fraction that contains polynomials. Now these fractions can look super complicated, but they can also be pretty simple. So for example, 1 over x is a rational expression. So we have a fraction and we've got a polynomial in it. Now our numerator can have just a constant like the number 1 or 2 or 7, but the denominator has to have a variable in it. So like I said, they can be simple like this guy, or they can get progressively more complicated. So we could have a 2x to the 5th over 3x plus 1. So now we've got a polynomial in the numerator and a polynomial in the denominator. Our denominator is a binomial, our numerator is a monomial. So what we're going to be looking at is how do we simplify these. So as these get more complicated, we will be looking to see if we can reduce our fractions. So like I said, we can have a trinomial in the top, and even just a binomial in the bottom. We're going to be looking at, can we make this any smaller? Now we've been simplifying fractions for a long time. We've never done it with polynomials in our fractions, but if we think about 12 over 16, if your teacher said make sure you reduce that, make sure you simplify it, most likely you would try to find the biggest number that divides both of these, which in this case is 4. And then we would reduce this all the way down to 3 over 4. So we've been simplifying fractions for a long time. What we're going to do is the same process. However, when we're trying to simplify a rational expression, finding the biggest thing that divides them can be really tricky and sometimes difficult. So we're going to think about this process just in a little bit different way, and then we're going to use that process and apply it to these problems. So instead of looking at 12 and 16 and thinking about what's the biggest thing that divides them, what if we thought about what are the factors? So what could we write 12 as if it were two factors? One set of factors of 12 is 3 and 4. So we can actually rewrite 12 into 3 times 4. And for 16, we can think of that as 4 times 4. And if you notice, once we write all their factors, this is still equal to 12 over 16. This numerator and this denominator both have 4's, which means they will divide to equal 1. And then 3 times 1 is 3 over 4. And we can actually reduce and get 3 over 4 just thinking about it a little bit differently. We're going to use this strategy up here. We're going to, instead of trying to find the biggest thing that's going to divide the numerator and the denominator, we're going to break our numerator and denominator into its factors and then see if we have any identical factors that will divide out to equal 1. And we're going to use that strategy to reduce our fractions. So with that in mind, let's look at our first example. So we've got 3y cubed over 6y to the 4th minus 3y cubed. Now, at first, your brain's probably going to want to see, oh, these are the same, let me just cancel those out. But the only way things are going to cancel out is if they divide to equal 1. And the only things that are going to divide to equal 1 are factors. So this 3y to the 3rd is not a factor of the bottom, it's actually just a part of the bottom. So before I can do any canceling or dividing, I have to actually factor. So let's factor the top, factor the bottom, same way we did up here, and see if there's anything that will divide. So the numerator is a monomial. Monomials do not factor. There's no greatest common factors coming out of one thing. There's no adding or subtracting, so we don't have two sets of parentheses. So our numerator will stay the same. Our denominator, remember like Miss Rutz said in her video from the other day, you're always going to look for a greatest common factor first. So 6y to the 4th and 3y to the 3rd, they both have a 3 in common. And they both have 3 y's in common. This one has 4, that one has 3, so we have 3 y's in common. So we're going to take that out as our greatest common factor, and then we're going to divide to see what we have left over. So that'll leave us 2y minus 1. Now when these divide, they don't disappear, they actually equal 1, so it's really important to make sure we write that 1 down. Okay, so now we have our numerator, which is just 3y to the third, but our denominator now is been factored. We have two things that are multiplying together to equal our product. So now that this has been factored, this entire factor will cancel with that entire factor. And remember, when they cancel, they leave a 1. So we're actually reducing this all the way down to 1 over 2y minus 1. Now, the 1 down here in the denominator cannot be canceled with this 1 in the numerator because this 1 is not a factor of the bottom, it's part of the bottom. So the only way you can cancel things out through division is if it's a factor divided by an entire factor. So this is the answer to the first one, simplified. All right, let's take a look at something a little bit different. Same idea, we're gonna factor things, look for their factors and then try to cancel out. But you'll notice this time in my numerator, I have a binomial. So just like we did on our problem up here, we're going to look for a greatest common factor. 4x squared and 9 actually don't have anything in common, no numbers in common, no x's in common, which means this is most likely going to fall under either difference of squares or a sum or difference of cubes. So this is a difference of squares because it's subtraction, and every part of my numerator is a perfect square. So it's going to factor into those two nearly identical parentheses, 1 plus and 1 minus. So we square root both pieces here, so 2x and 3, 2x and 3, one's positive, one's negative. All right, so our denominator is a trinomial. First, we're going to look for a greatest common factor. But there's no x's in common, and 2, 1, and 3 do not have any numbers in common. So with trinomials, you can either guess and check, or you can factor by grouping. It's your choice, whichever one you like the best. This time around, I'm going to guess and check. So what multiplies to 2? 1 and 2. What multiplies to 3? 1 and 3. I want to multiply to a negative, so I need 1 positive and 1 negative. I love guess and check when my numbers are prime because there's not too many choices, so usually I can get it pretty quickly. So trying to get a 1 in the middle, so with a 3 and a 1, I'm going to have to put my 3 here and my 1 here. Also just doing a little logical thinking. If our goal is to get factors on the top to cancel with factors on the bottom, we probably want one of our parentheses to look like one on the top. So I'm going to start here, just check it, and then see if it is right. So these two would give us 2x squared, which is our front part, then a 2x and a 3x. If we subtracted those, could give me a negative 1x, and then a 3 and a 1 will give me a 3. We know we need a negative x in the middle, so my 3 is going to have to be the negative, so that's how the denominator is going to factor. All right, so now we have two factors on the top, two factors on the bottom. We're going to cancel out entire factors by dividing them. So 2x minus 3 divided by 2x minus 3 will leave me 1. These guys are not identical, so they cannot be canceled at all or divided. So I'm just going to write 2x plus 3 and x plus 1. So it's 2x plus 3 times 1. And now I'm going to see if I can do anything else. Now remember, this is an entire factor. It can only cancel with another entire factor. So the x from this 2x cannot cancel with this x from the x plus 1 because this isn't an x, it's an x plus 1. It's an entire factor, which means this is our answer. It's the best we can do. Okay, just a couple more examples here. Example 3, we've got a little different kind of factoring going to go on here. So we're still going to do the same thing. We're going to try to factor it out and see if we have any identical factors on the numerator and the denominator and see if they'll divide to give us 1. So we've got another binomial. There is no greatest common factor. This is not a difference of squares because it's adding. So we want to check to see if it's a sum of cubes. So 8 is 2 cubed, so it's a cube, and x cubed is clearly a cube. It has a name cubed. So this is a sum of cubes. So maybe you remember how this factors. It's going to factor into a binomial times a trinomial. We're going to cube root the first term and cube root the second term. And now we're going to use these two numbers to help us fill in our second parenthesis. So we're going to square the first term, multiply these two terms, and then square the last term. And you may notice that I left my signs blank. I'm going to fill those in with that acronym SOAP, Same, opposite, always positive. So same is the same as the original, opposite, always positive. All right, so the top is factored. Don't forget this part here is not going to factor when you do sum or difference of cubes, so we know we can't make that any smaller. All right, for this problem down here, we've got another trinomial. This one actually does have a greatest common factor. It's 2x, so we're going to take a 2x out, which means we're going to divide everything by 2x, and that will leave us with x squared minus 2x plus 4. And logically thinking, something's going to have to cancel. These two parts are not identical, so they're not going to cancel. So most likely it was going to be these two parts that were going to cancel. So now we've got a factor, a factor, a factor, a factor. Now even though this isn't in parentheses, if you'd like to put in parentheses to just kind of visualize that it's its own factor, please feel free to do that. Now these two factors are identical, so they'll divide to give me 1. So let's look what we have left. Now the x up here and the x in the denominator will not cancel because this x is a factor, its whole factor is x plus 2, and it can only cancel as an entire factor. Same with the 2. The 2 can only cancel as an entire factor, so it cannot cancel with that 2 there. So this is our answer. All right, so we have greatest common factor, difference of squared, sum of cubes. The only thing we haven't done yet is factoring by grouping. So that's what we're going to tackle this last one with. So you can see that we have 4 terms at the top. We're going to look for a greatest common factor first. Unfortunately, there is not one. So remember when we're doing when we are factoring by grouping, we're going to group our first 2 terms, look for a greatest common factor, group our second 2 terms, look for a greatest common factor. So first 2 terms, greatest common factor is 2x squared. So if I take a 2x squared out, it's going to leave me x plus 3. And if I look at my second group, they actually don't have a greatest common factor besides 1, so the only thing we can take out is a 1. It's actually really important when you're factoring by grouping to write the 1 down, even if it's the only thing you can take out, because remember, that 1 becomes part of our factors. So if I take a 1 out, nothing's going to happen. We're going to have x plus 3 left. All right, last step here then is to rewrite this as just a product. So we're going to have x plus 3 times 2x squared plus 1. Squeeze it in there. All right, so that's my numerator. Now let's tackle the denominator. Now your denominator, you can guess and check if you want. You can also factor by grouping. So I'm going to just do the grouping since we're kind of new to this. Some of us haven't seen this before. So we're going to multiply a times c. So that's going to be 1 times negative 12. And we're looking for 2 numbers that are going to multiply to negative 12 but add to negative 1. So we're going to look at our factors of negative 12. So 1 and 12, 2 and 6, 3 and 4. And if we're trying to multiply to a negative, one of these one of the numbers of the 2 factors are going to have to be negative. So I need a negative x in the middle. So that's going to mean 3 and 4 with our 4 as the negative. So just rewrite this guy, x squared minus 4x plus 3x minus 12. It doesn't matter which order you write these two. You could write the 3x first, then negative 4x. All right, first group, greatest common factor is x. So if we take an x out, we're going to be left with x minus 4. Second group, greatest common factor, 3. And if we take a 3 out, we're going to be left with x minus 4. So that's going to leave me with the parentheses of x minus 4 and x plus 3. All right, so now we're ready to look for entire factors that will cancel out and divide to give us 1. Now, even though this x plus 3 and this x plus 3 are not stacked on top of each other, that's okay. They're still going to cancel each other out when we divide them to equal 1. So if we look at what we have left, we're going to have 2x squared plus 1 over x minus 4. Now 2x squared plus 1 is an entire factor. Now you may have noticed on my last step for all of these problems, I took the parentheses off. I don't need them there because I'm not multiplying it by anything, so I don't have to show that it's grouped together. So if you'd like to leave them, by all means leave them, but they're not necessary now because I don't have to show it's one group because there's nothing else happening on either side of it. So the x squared and this x will not cancel because the x squared is part of all of that. We can't just cancel individual parts. We can only cancel entire factors, which means that's our answer. If you have any questions about any of this, please reach out. Otherwise, you have a fantastic day.